giving you a motivation here. Okay, what is the motivation? Okay, we are going to have an exam number 3 at the end of this week, which is on Friday. Okay, if you do well, right? What do I mean well? If you do 75% or better, right, then you have the option to actually replace one of your exam with this exam as well. Okay, so that gives you a motivation to bring up your grade. Okay, for those of you who didn't do so well on your exam number 1 or exam number 2, I'm still grading on your exam number 2 right now, right? Because you finished on Saturday midnight, right? So I got that, and then I'm grading it right now, right? In process of grading. Okay, so far so good. Okay, so what we want to do is focus on all the work, right, that needs to be done this week and do well on the exam this week on Friday. Okay, and that's what we want to actually focus on. Okay, not any other works the before. Okay, we could actually worry about that after the exam. Okay, after the exam. What you want to worry about is this exam, because you want to do really well on this exam to bump you up, right? So if you do well on this exam, right, then you're going to replace your lowest score on your other 2 exams with this exam as well, okay? Okay, it will help you along, okay? That gives you a motivation, okay? So far, so good. Any question? Okay, all right. Besides that, I talk to those people I need to see and then try to help you guys out, right? Javante, you stick around, right? David, right? We have Jackson and Angelica. Okay, those 4 people. I want you. Okay, Jesse, either Jesse or Joe, you make us a breakout room, and then we'll see each other at the end of the class, right? So we'll try to get you situated with maybe a one-on-one trainer. Okay. Besides that, do you guys have any question before we start on our new information? Okay, everyone have their names on the chat here. Everyone show their phone and phones. Everyone phones. Okay, thank you. Okay, put away. Okay, away, all the way away, right? Okay, thank you. All right. Okay, so what we're going to be doing is we're going to get into, when I actually teach this traditionally in class, right? This is divided into two halves. The first half is what we did up to just now, what we call the descriptive statistic. Okay, descriptive statistic is basically gathering data, organizing that data, and summarizing that data, okay, for it to be readable and usable. Okay, so far so good. Okay, so second part of your statistic consists of what we call inferential statistic. Okay, so what do you do with that summary of the data that you collected? Okay, we're gonna inference about information that we're wanting to find, which is what we call, normally, most of the time, we're looking to find what we call a population parameter. Okay, population parameter. Okay, what do you mean by population parameter? So we're looking for maybe the population mean, population standard deviation, population proportion, all these different type of population. Because population, the information about population is extremely difficult to get. So far, so good. Any question? Okay, so what we want to do is inferential statistic. You want to guesstimate what the population is, and we want to guesstimate that population information, not just out of the blue, but we want to have an educated guess, right? So far, so good. Okay, so now for MVP point. Okay, so let's see, right? If you could give me a range, if you could actually write this on the chat, what my weight will be, okay? Give me a range of value, right? Where you think what my weight will be. What will be my weight? Okay. How much do I weigh, basically, right? So on the chat, let me have you actually write this down, right? Give me a range of value. Okay. So closer one, people who have the closest one, couple of people I would choose, right? The closest together, right? Wins MVP points here. All right, good. Coming in. Ooh. 170 to 200. That's a big range. That's about right. Range of 30 right there, right? So 170 to 190, 170 to 180. I get, who put 195 to 185? Okay, when you write your range, you write from the smallest to biggest, right? Victoria, right? 185 to 195. Very good. Okay, so we have a range here is about, you say, oh, 190, give or take probably 5 pounds there, right? So 180 to 200, 175 to 185, 175 to 185, 170 to 190, 185, 195. Okay, there are two winners. So, okay, oh no. I'll give, so again, 175 Jackson. Okay, I am 6'1", right? And I'll give it to here. Victoria wins MVP point. And let's see here. Amir, that's the closest. I weigh about 188, 190. Okay, 188, 190. Which means Javante wins. Let's give those three, right? So how confident were you that you actually got my weight with those range? Okay, you could unmute yourself. Okay, Victoria, how confident were you that, you actually retained my weight?
I was really confident.
I just guessed.
You guessed, right? Were you confident? Very confident? Less confident? Like 50% confident?
I was confident because I remember last time you were saying you were around like 6'1", so.
Oh, good. So your confidence level was pretty big, right?
Yeah.
How about Jasmine? What about yours?
I also kind of remember you mentioning that you were like 6'1", but I. So it was.
But you don't know how, like, different, right? Even though I'm 6'1", I could be very skinny 6'1", or I could be like fat 6'1", but you could tell by, looking at me, right? So basically what we're going to be learning today is actually figuring out what we call the confidence interval, okay? So basic idea is this is exactly the big idea of what confidence interval is all about, okay? What you're trying to do is, right, have what we call, so if you're actually trying to guess my weight, right, you wouldn't say, oh, I'm 100% confident that he's between, right, 0 pound and 500 pound, right? You're like, no, duh, everyone's pretty much, 0 pounds to 500 pounds, right? I'm 100% confident, even though your confidence level is off the roof, right? 100%, but that doesn't tell me anything about, right? Everybody's pretty much, right, fits between 0 and 500 pounds, right? So far, so good, right? But what we want to do is we want to figure out his accurate weight with the confidence level to be high, right? And how do you do this? You could actually do this by looking at his stature, right? How physique, how tall it is, right? How bony it is or how chunky it is, right? And so forth. And just by looking at his stature, we can actually kind of gauge, right, what his weight might be, right? So far, so good, right? And then your confidence level gets higher because, having more information also boosts your confidence. You're like, he told me that he was 6'1", right? If I did not tell you and I told you I was like 5'5", right? Then you'll be completely wrong, right? Get the idea, right? So far, so good. And this is the overview. You think of my weight as your population mean of, say, average weight of a male, right? And what we're trying to do is we're trying to gauge the population mean of a male, right, person, right, adult male person in the United States. And you say, oh, you give yourself a range, and then you say, oh, my confidence level is this, and we're trying to figure out the population parameter that way. Okay, so far so good. Okay, get the idea. Okay? Another analogy that I like to use is, I do this often when I'm actually teaching in class. Okay. So I ask you, oh, okay, if I give you a target, okay, and I'm gonna give you like a spit walk, okay? Okay, so if this isn't actually in class, right? Okay, if this is actually in class wherever you're setting, correspondingly where you're setting, I give you a spit walk and I ask you to hit this target, okay? So how confident are you that hitting this target? So say Jackson, what will be your confidence level here?
It would be smaller compared to like if it was a bigger target.
Right. So suppose that this is right here. So how confident you'll be to hit this target right here?
Not that actually, I have pretty good accuracy. So
you're like, I'm an athlete. You know, I could hit anything pretty much. Right?
I feel like I could hit it. Like for the average individual, I feel like their confidence wouldn't be that high.
Right. So you'll say, you know, maybe 1% to what, 5% that you could hit this target with the spitwad, right?
Oh, with the spitball.
Or yeah, spitball.
Oh, you know, I don't know about that. So.
Oh, you don't know,
yeah,
right? So this is 1 to 5%. So what if I make this a little bit bigger?
Oh yeah, that looks like. I feel like I can do it.
All right, better. Your confidence level, what happens to your confidence level?
Goes up.
Goes up. So what would you gauge? Isabella, what would you gauge? If it was the purple one is 1 to 5%, what would you say? What would your confidence level be for this one?
For the purple one or the green one?
So the green one.
I feel like I'm 10% confident that I'll make it on the target.
About what? What was it? What did you say?
10%.
10%? About 10%?
Yeah.
Okay. All right. So let's see. How about this blue target? Okay. For sure.
I'm hitting.
What about you? What would be your confidence level for this one right here?
Like 75.
75. You're like, I'm an athlete. Right? How about Angelica? So as you notice that as it gets bigger and bigger, your target size gets bigger, what happens to your confidence level?
It increases.
Right, increases. So if you're given this target right here, so what would be your confidence level to hit this target right here?
That would probably be my 75%.
Oh, that would have been your 75. We'll just say 85%, right? And then let's just do finally huge target right here, right? Okay, can you hit this, right? Jasmine, what would your confidence level be?
Like 95, 100%.
95 to 100%, good.
Are we talking about hitting it from like only
like where you're setting, whatever,
or like
it
the
is?
whole circle?
The whole,
because
it doesn't matter. Any part of the target here.
Okay.
Yeah, not
Part of the interior.
Right. Hitting the target. So far, so good, right? So you notice that as the target size gets bigger and bigger, your confidence level goes up and up, right? Just like guessing, right? Trying to actually guess the population parameter. Say like, guess my weight. If I'm the population right here, and you're trying to guess my weight, you could have said, oh, you're between 0 and 500 pounds. I'm 100% confident that you're actually between 0 and 500. No duh, everyone's probably between 0 and 500 pounds, right? Get the idea, right? So far, so good. It doesn't tell me dilly squat if you have, right, a huge range, which is what we call the big target, okay? Yeah, you could hit a big target, right? Anyone could hit that. Any blind man could hit that, right? Okay, but are you accurate? Are you accurate? Not really. Your confidence level is good that you're going to hit the target, but are you accurate? Can you actually hit the bullseye here? No, that's going to be, right? So in order for us to increase our accuracy, right? I know you guys are all athletes here, right? What do you need to do, Amir? Okay. What sports do you play?
I play basketball.
Basketball. To increase your accuracy of free throw shooting, what do you do?
Practice.
Practice, right? You need to practice, right? And practice takes time, right? Get the idea. In the sense of statistic, right? In order to be accurate and boost our confidence level up, you need to practice. Same idea. In order to do that in statistical analogy, we need to actually take the sample size and bigger sample size. It's basically shooting more and more free throw, okay? To be a better and better free throw shooter, okay? Get the idea, right? Bigger and bigger sample size. Basically, so now that Amir has actually shoot, say, 100,000 free throws, right? He's like, oh, no, I don't need this. Or say he's taken 100,000, or maybe, let's just say, 100 shots. Let's just say 100 shots. Oh, he says, okay, before he was at 95 to 100% to hit that red target. Now he's saying that, oh, I could hit this. Oops, sorry. I could hit this right here, the pink target. Now that I shot about 100 times, I could hit this right here, the pink target, about 95 to 100% of the time. Okay? So you could say, oh, now I could say, I could hit this with practice. The confidence level actually goes up with a smaller target. You notice this right here, 90 to about 100% of the time. You could hit this, right? Now, suppose that you shot it, or you try shooting at this another, 1,000 times. Okay, you notice this? I could decrease this and say, oh, my confidence levels actually shot up because I'm more accurate at this, because I have practice at this, so I could hit this better. So now my confidence stays exactly the same, but I could hit a smaller target. Okay, and that's the overview of what your confidence interval is all about. You're trying to shrink. So in statistics, we're able to actually shrink the confidence interval down, become more accurate by using what we call the sample size to accurately contain what we call the population parameter. And Joel, I got to give credit to Joel, right? He did a wonderful job here, okay? When we talk about, so when we go here, let's see. If you type in this, so let me give you guys a minute to actually type in this to your web browser. So we have www.desmos, right? And calculate. So I'm gonna share this.
I'll type in the link into the chat right now, I think.
Oh, yeah, I'm almost there. RM.
Okay.
8HTFWZIF. And I got this. Oh, this is wonderful. Okay. And let me unshare this. Okay. This is the visual perspective and what you're trying to do. You're trying to capture the population parameter. Okay. So let me actually share this. You're trying to capture the population parameter, right? Using a big old net. Bigger the net you have, of course, better chance of capturing that population parameter. Smaller the net you have, right? You have a lesser chance of capturing that parameter, right? So that represents what we call the confidence level, okay? Confidence level of capturing that, right? And you could actually play around with this, and you notice that it becomes bigger, smaller, right? To capture that parameter here. And we could have that moved, right? In and out. And this is your population proportion, okay? And that's your p-hat value, okay? How to actually capture that p-hat and increase the size and also capture that population, right? That's what we call the queenfish. We want to capture the queenfish as well as the worker fishes over here, okay? Because we're greedy, right? Okay? And that's what we're trying to do right here, okay? So look into this and also read the text, okay? So, but the general idea is, is exactly what I asked you about the target size, right? So the bigger target size, your confidence level goes up, right? Smaller the target size, your confidence level goes down. But with practice, right? But with practice, you're able to shrink the target size and increase your confidence interval to contain and capture your population mean, like what you did before. Okay, so far so good. That's the kind of the overview of what we're looking at. And the population that we're looking at, population parameter that we're going to be looking at are going to be the mean, proportion, and standard deviation. Those three we're going to concentrate on. Okay, so let me actually, without further ado, go into the text here. Okay. All right, so here, so in this unit number 3, we're going to be doing what we call this inferential statistic. We want to actually, with given summary of data, we want to actually make some type of conclusion about a population, and that's what we call the inferential statistic. Okay, and how do we do that? By defining what we call the confidence interval. Okay, confidence interval. What you need to know, what a confidence interval is, and which I explained, which and for which parameter we will build confidence interval, how to read and interpret confidence interval in context, how to make decision and form conclusion based on the information from a confidence interval. And that's what we're going to be looking at. Okay, so the most interesting question in statistics are always the ones concerning population, okay? Because we do not have enough time and resource to actually collect all population data, okay? Concerning about population. We want to know things like what is the mean of the vote for Heisman Trophy winners, what percentage of WNBA games go into overtime. These values, when summarizing a population, are called parameters, okay? Population parameter, they go in hand, right? The problem with these questions is that the populations are so massive that we can never possibly properly survey or measure the entire group and actually find the value of the parameter we seek. So what do? We instead collect information from a sample of population, sample of the population instead, okay? And so what's the definition of statistic? What is the definition of statistic? Victoria, what's the definition of statistics?
Data.
Sample data, sample, look here. When we find summary value for sample instead of the population, we call that statistic. That's what this class is all about. What's the title of this class? Angelica, what's the title of this class?
Stats in motion.
Stats, right? Statistics, right? Okay, the title is statistic. We're learning about statistic, which means that we're learning about sample, not population, right? Sample data, right? And what we're trying to do is we want to approximate the population parameter, population value. What is your population mean? What is your population standard deviation? What's the population proportion using sample rather than what? The whole population, because a lot of the time it's impossible to get that population information. Okay, so far so good. Okay, so how do we estimate the parameter given a statistic and trust that our estimation is accurate? We take sample. Okay, so we do the same thing that we probably do when someone asks how you, oh no, let's go through all this right here. So if I ask you to say, oh, figure out the, right, average weight of Cerritos College student. So what would you do? Javante, what would you do? Hey, Javante, by the way, I know that you're comfortable and all, and I think, right, if you don't mind, if you actually kind of, yeah, more professional. Good, thank you.
What was the question?
Huh?
You said, how do I find out
so if I want to figure out the average weight of Cerritos College student, what would I do? What would you do? All Cerritos College student, average weight of Cerritos College student.
You got to gather all the data.
Right, gather all the data. Is it possible to gather every population of Cerritos College and weigh them?
No, because it's too many.
You'll probably get some butt kicked by some, ladies out there who doesn't want to be weighed, right? Okay, or even males, right? Okay, right?
Yeah.
Sensitive about their weight, right? So, but it's going to be very, very difficult to actually measure every single person's weight of Cerritos College student. So what do? You rely on what? Sample data, right? You rely on sample, right? Suppose that you're able to actually gather 100 sample, right? Okay, 100 Cerritos College student, and you measure them. Is that going to represent the population?
No.
No, but you could get close to it, and you could get, you could have a rough idea of, oh, what is the average weight? What range you should be? How confident our range will be, right? We could actually figure out a lot of information just through the sample about the population, and that's what we're trying to do. So 100 is not good enough, right? What about 1,000 people? Is that better? Yeah, you're going to have better, right? Okay, so you guys say, suppose that, oh, it came out to be 150 pounds. And then you could say, oh, I could figure out, oh, give or take maybe 140, and then give or take 10 pounds, 140 and 160 pounds, right? I'm pretty confident, like 60% confident maybe, right? But if I gather more data, I could become more and more confident, okay? So first so good. Okay, I'm gonna just let you read all these right here. The big idea about confidence interval, right? I'm gonna have you read this spear fishing right here, because this is Joel's idea. Okay, Joel this. Okay,
no,
this is your trainer right here. Huh?
Well, I don't want to take credit. It's Professor Conley's idea, but she had me animate
Professor Conley's idea, but Joe actually made it much more visual. Going through this, going through that website right here, going through this right here. Okay, and that's what this is containing right here. Okay, what we want to do is we want to learn how to actually interpret it as well. Okay, what is the value that we get, and what does that really mean? Okay, how to interpret that data. Understanding and interpreting confidence interval can be broken into 3 parts. Okay, color coded here. So what parameter are we estimating? Okay, what are we approximating? Are you doing proportion, mean, standard deviation? What are we doing? Given information, they'll tell you what type of information, right? And usually they'll tell you what confidence level to use. If not, you most likely will be using confidence level between 90 to 99%, okay? But there are cases where we could use 80%, 70%, and so forth, okay? Okay, but a lot of the time we try not to use something like that. We want to have a high confidence to actually obtain, right, the value, Okay. Number 3, what are the upper and lower boundaries of the interval in context? So if I ask you, I think I asked you, consider my weight to be population mean. Okay. So I ask you, oh, give me a range where my weight be. Someone said, oh, you're between 180 pounds, right? Give or take 10 pounds. Okay, this right here is considered to be, later on you'll learn that this is considered to be margin of error. That's your give or take. Okay, so first we'll get, that's your margin of error. Okay, so Angelica, what will be the low value of my range? So I'm, say you guess that my weight is 180 pounds, give or take 10 pounds. What will be my lower range of this value?
170.
Very good. Give her an MVP point. What would be the upper range then?
190.
190, good. Okay, so far so good. So basically, this is what we consider to be our lower bound, and this is considered to be my upper bound. Okay, upper and lower. Okay, so far so good. Okay, so when we see a phrase like 90%, right, confidence interval for a mean time in seconds of salmon run game in Splatoon 2 is 240 to 260, then we would actually translate this into, we are 90% confident that the mean time for the game of Salmon Run in Splatoon is between 200, so population mean is going to be between 240 and 260 seconds long. Okay, that will be the mean time. So first again, another interpretation, let's look at this. When we read proportion of US citizen that travels overseas is 0.0377. This is in decimal form, and 0.0474, right? 95%, I'm 95% confident, right, that there are between 0.0377, 0.0474. We can interpret that we are 95% confident that proportion of the US citizen who travel, right, overseas is going to be between 3.77% and 4.74%. Okay, that is how you would translate this. Any questions so far? So far, so good? All right. So now let's see here, Berta, right? If I ask you, right, would this be higher today or lower today? You could unmute. Would this be higher today or lower today?
Lower.
Why lower?
Because less people are traveling right now.
Right now, I know the COVID-19, no one's actually traveling, no one's going nowhere, right? Yeah, because I know that if you actually go outside from United States, every country that you travel to, you're actually quarantined 2 weeks in place. So if you go outside of, say, United States to any European country, you have to stay in that hotel room for 2 weeks without coming out. Okay, note that you're actually safe to actually travel afterwards. Yeah, no one's going to be traveling nowadays, right? It's going to be much, much lower. Okay, so far so good, right? Any question? Okay. Again, so what where was this? There was over here. Joe, do you know where? Oh, here. The bigger the net, so I want you to kind of read this carefully, okay? So in order to actually shrink the size of the net, so when they describe about this queen fish and the worker fish, and we're trying to obtain the queen fish, which is our population proportion here, right? So what we want to do is we want to actually increase the confidence level, right? And decrease the size, right? We want to be precise, and gives you a direction how to actually, right? So what you need to do in order to actually capture that, right, population proportion, right, without compromising your net. Okay. So far, so good. Any question? All right. So without further ado, I actually only want to do one other thing. So let me do an example problem that I have here. Okay. All right. I know you guys are all coming up to those drinking age, right? And you guys are all about drinking, right? Let's actually look at this right here, okay? So drinking habits, okay? So we're gonna look at, right, capturing what we call the population proportion here, okay? So drinking habit, a Reader Digest Gallup survey in the drinking habit of American estimates that the percentage of adults across country who drink beer, wine, or liquor, or right, at least occasionally, maybe once in a week, once in a while, right? Right, couple of times, few times a month, right? That's occasional, right? Of the 1,516 adult interview, 985 say they drank. Okay, so this right here represents what we call the sample size N, and this is R. X equals to 985. Let me have you write this down. Also, open up your StatCrunch as well. Okay? So far, so good, right? So if I ask David, can I ask you, what would you say, what proportion of adult American actually drink? If you had to guess.
Just guess?
Uh-huh.
So, let's just say like 900 adults.
No. Proportion. Proportion.
Oh, proportion.
Percentage.
Oh, sorry. I thought you meant the problem. I don't know. Just make up a guess. You said.
Yeah, just guess. There's no wrong answer.
Or like 1 million, I guess.
Yeah, no hint.
Should say.
It is hard, right?
Yeah.
Putting you on the spot. Just give me a number.
Some drink, some don't.
Yeah, give me a number.
Yeah.
Give me a number percentage.
Oh, a percentage. Just say 90%.
90% occasionally drink. 90% occasionally drink. That's a pretty big number, right? Okay. So you're like, if you don't have any information about, proportion of drinking, right? You would have to actually refer to your experience, right? Or your, experience, throughout your looking at adults, right? But if you have a little bit of information, you notice that we have a little bit of information of the 1,500 people actually we surveyed. Of that, how many said they drank? 985 out of 1,516. Okay, we'll just call that P. Okay, and if you put that into a calculator, we get approximately 0.65. So would you have a better guess? Jasmine, what would you guess now?
Sorry?
What would you guess now, knowing that the sample is 65%? What would you guess the population will be? What's the population proportion? What percentage of adult occasionally drink?
25%.
What? Where'd you get that? Jackson, what would you guess?
For the percentage?
Proportion.
The proportion out of how many people do what?
Richard, what would you guess?
Like as a percentage or decimal? I'd guess like 70.
Yeah, because look here. They say it's 65 because out of the survey people of 1,500, right? 1,516. I know a little bit about it now. They say it came out to be 65% of that people actually drank. So we could say, I could say roughly about 65%, 60 to maybe 70% of the people actually drink, right? Right? Occasionally, we could say, knowing a little bit of information, we could say, roughly 60 to 70%, right? We have a better idea with Okay, it's not like you're throwing a, you're blindly throwing a dart, right? You have a little bit of information which gives you a leeway, right? To make a better estimation. Okay, so far so good. Is this a good estimation? So what we need to do is utilize this information, and then we're gonna figure out the actual percentage, the population proportion, percentage of people who actually drink. Okay, so now, in order to actually, excuse me?
Sorry, I had a quick question. Wasn't it square rooted? Like the...
Oh, no, don't worry about that. Don't worry about any of those, right? Just look at this one right here. So what will be our Q? What will be our Q? If P represents the probability, right, which is your P represents the probability of success, what's the Q? What's this complement, which is your probability of failure? So 0.35, very good. That will be your, or 35%. So this will be 65%. So far, so good. Okay. Now, let's verify. Okay, verify the requirement for constructing a confidence interval about P are satisfied. Okay, in order to verify the requirement, it's got to be what we call the normal distribution. In order to be a normal distribution, it's got to meet the three conditions. What are the three conditions? We just talked about in exam number 2, which is an important idea. Victoria, do you remember? For MVP point?
Central limit theorem, that one?
Very good. Give her MVP, central limit theorem. Okay, anyone know what those three conditions are for MVP points?
Simple random sample.
Okay, that's Jasmine, right? Simple random sample, very good. Okay, what's your second condition?
A large population.
Third condition is large population.
25 or NP
you don't necessarily have to kind of know the exact, just large what? Sample. Yeah. Large sample size, right? And what is large sample size? For proportion, n times p and n times q has to be greater than or equal to 10, okay? For mean, it's got to be greater than or equal to 25. Okay, so far so good. So we're going to assume that these three conditions are met. Okay, so far so good. Now, what do we need to do? Okay, we're almost there, right? We want to construct a 90%, 95% interval. Okay, I'm going to share. You guys all have your Stack Crunches open. Okay. Let's go to StackCrunch here, and we're gonna do here, go to stack, go to proportion, because we're talking about a proportion, population proportion. We wanna estimate one sample with summary data, okay? Go here. Number of success is the X value, okay? That was 985. That was 985. And we have observation. The survey we took was 1,516. And we want to figure out the confidence interval, right? For the proportion, confidence level at 95%. And I'm looking at 95% confidence interval, okay? And when we compute, and we get this, and what we want to do is we want to figure out these two values, okay? And this is, so Joel and Jesse will help you out with a lot of different, because you're going to be looking at a lot of different confidence interval and calculating using StackCrunch. Don't worry about the formula per se, okay? Know what you're dealing with. It's more important that what data are we dealing with? Are we dealing with proportion? Are we dealing with mean? Are we dealing with standard deviation? Then according to that, you need to know how to use that with the StackCrunch, okay? So first we get. So now let me have you jot that down. I'm gonna jot that down as well. Okay. So it says 0.6257, 0.6737. And then let me stop sharing this. And then let me share this. It's just saying, I think I'm running out of time here, Joel. And I need to other students here. Okay, I think I asked Jesse. So here, I just want you to, can you write the interpretation for them? Okay, what does that mean? What does this mean? They're saying that I am 95%, we are 95% confident that the proportion of adults across country who drink beer, wine, and liquor occasionally will range between, so our population proportion will be between 62.57% and 67.37%. That's pretty good guess with just limited, right? We never even took the whole population, the survey of whole population. We only took about 1,516. How many adult Americans are there? There are probably about 100 million people. To take the survey of more than 100 million people is gonna take you days and months, right? And you're gonna spend a lot of money. But look here, this is actually close enough, right? You notice this right here? That's a pretty darn close approximation. I am 95% the population proportion is gonna be between 62%, 63%, and 67%. Then if I'm a owner of Bermo who sells liquors, right? I could say, oh, wow, majority of people actually occasionally drink. I'm going to stock up on this is a good business to actually get into, right? You could think about that, okay? So first of all, get the idea, and you need to know how to interpret this. Interpretation is very important, okay? All right, so now, okay. I think Joe will actually elaborate on this. I'm going to actually make Joe, I'm going to have you, I'm going to make you the host.
Okay, and then I'll create a breakout room and I'll
right, I'm going to have Jackson. Can you also come in for a second? Or either Jesse or Joe, who does the lecture or who does the tutoring?
Yeah.
Joe, so Jesse, can you come in with me?
Yeah. Okay.
Jackson, David, I need Javante, Angelica, and who else was it?
That was the only 4.
That was only 4, yes. Can you put me in the breakout room
Angelica,
really quickly?
Repeat again. Angelica, Jackson.
Angelica, Jackson, Javante,
David.
And David.
Got it. And just there.
Okay, great.
Okay, so I want to make sure that the diagram with the fish made sense. Because I don't know how many of you read the chapter last night or the PDF, right? So tell me, again, I try to summarize the section. So here is my paragraph, read it and tell me, there's a lot of words, by the way. I've noticed that because we have so many P words, we end up confusing things. So we have proportion, we have parameter, we have population, right? So don't confuse those things. You have population parameters. You have and a proportion is a population parameter. But we also have a mean or average is a population parameter. And you could also have a standard deviation as a population parameter. So
I have a question.
Yes.
How do you find Q again? Because I forgot.
It is the complement of the proportion. So if P were to be lowercase p, because then we have uppercase P for probability. So you see, I'm trying to, real quick, I'm going to answer your question, but as you read my paragraph on the side, every word that I've mentioned there needs to be a vocabulary word that you kind of know what I'm saying. Right? But so back to you. We have capital P for probability and lowercase p for proportion. And then we have P hat for proportion also. So the question is, what are the two P's? Regular P is a population parameter proportion. P hat is a statistic proportion, which is, it means it's part of the sample, right? So you have the population, and then regular P is a proportion for this population, and that's called a parameter. Then you have P hat, and that's for a subgroup, and in this subgroup you also have a proportion, so we call it a statistic. And so we distinguish which one we're talking about by using P or P hat.
Okay.
And then the same thing will go for Q and Q hat. Q just means the remaining from 100% for P, and Q hat is the remaining from 100% for P hat. So I think Q hat is the remaining percent for P hat. Does that make sense?
Okay. Yeah, thank you.
Very simply, if P was 10%, Q would be 90%. If P hat was 30%, Q hat would be 70%. All right, so again, take the time to read the paragraph and tell me if you get what's happening. Oh, sorry, ask me if you don't understand what's happening. Okay, so I'm going to share my screen and I'm going to talk about my paragraph, so at least you have an idea what all that jumbly wordy stuff was going on.
Thank
You
God.
guys? Yes? Sorry, someone say something? Okay, here we go. So, what is that paragraph saying? Look, you guys have already spent about 2 weeks figuring out where data's falling. So the Gettysburg Address was a pretty neat example. So was the senators. Okay. For example, if this was 0 and 100%, this would be the senators. But if you had zero and I think maybe like 10, where the mean length of words. Okay. The senators, you can't really classify the senators with numbers, right? They're just these Democrat or Republican, and it was like, if you counted them all, it would look like that, right? By taking a sample of 10, a repeated number of times, you were able to create a chart that looks something like this, where some of your p hats were like 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. That makes sense? Everybody paying attention? Okay. So, like, taking 10 looking at those 10, every single time, they vary. But you never got one that, I mean, some of you might have gotten a p hat or proportion, a sample size, right? That was 100%, meaning 10 out of 10, 10 out of 10 Democrats, right? Or you could have had a different p hat, which is 0%, and that was 0 out of 10. But if you saw everyone's chart, you saw that you didn't get many of those, right? Amongst the 3 students you discussed or checked your numbers and your chart, everyone's chart mostly had a bunch of 0.3s and 0.4s and 0.5s and 0.6s and 0.7s. But even then, you even kind of saw there were more 0.4s and more 0.5s and more 0.6s. And there were the most like 0.5s. So the story goes is these sample proportions, right, are not straying far from the true population proportion. So that's why we use the analogy of having a school of fish, right? You know, all the fish kind of, or also, you could also use bees, right? But you center around the queen fish or this central fish, right? This important fish that has a certain status amongst the entire school of fish. And they swim around and they sway. And if I were to randomly pick one and understand that if I'm able to capture one, I must not be far away from the queen to begin with, right? That's the main idea. Question? All right, just mute yourself if you have like a video or having a conversation. All right. So, where's my graph? My bad. So this drawing without that storyline won't make sense. And also, I'm trying to figure out how to draw many, many fish. Took me a time just to place a couple fish here. But as you can see, I'm trying to do something like this. Right? So as you can see, there's several fish here. I'll figure it out later. But my goal right now is for you to at least envision having numerous fish here. Well, okay. Right? These are my fish. I should be able to draw better fish than that. There we go. Okay, so you're gonna have a ton of fish right now. Just to save time, you have fish everywhere. But these fish are really, for now, they look like one fish, but each fish is actually a collection of 10 fish or 100 fish or 50 fish, but it's a numerical value, like the population parameter that we got, sample proportions that we got for the senators. So each one of these is a p hat. And I tried drawing this for a few that came into tutoring, where again, the distribution, you should envision p hats everywhere. Okay. Now for the words, we had length and it was mean length. So you also got dot plot, like it was I think the mean was 4, right? But I'm talking about the ones that weren't biased, where you don't select the length of the word yourself, but you did the random one. Your dot plots would start to look like this, right? Okay, so right there, instead you should be envisioning X bars. Numerous X bars that you collected. You get what I'm saying? When we took the 5 words from the Gettysburg Address, from the random number generator from 100 to 268, okay? each one had a length. You took the 5, you averaged it and got like 4.1. You took another 5 and got 4.2. You took another 5 and got 4.3. You took another 5 and got 5.1. And you kept doing this. These are X bars, numerous X bars, and they all seem to cluster. And this is the amazing part. The theory behind this class is X bar, sorry, not X bar, mu, the population, mu will be centered on that distribution. And also P, remember I just discussed the difference between P and P hat. P is called the true population proportion. And so P will be centered amongst all those those various sample proportions. Is it making sense? So we're going to be able to predict where this queen fish is and also measure by how often and how accurate we will be able to capture that population proportion. So here's what I'm saying. Let's say there's a random fish, like the true population proportion is 50% here for this case, right? If the queen is always at 50%, for example, in this drawing, there's a random fish swimming about, and I happen to just like, actually, let's see if I can do this. It might be interesting. Okay, someone tell me when to hit stop.
Stop.
Okay, so I just found a school of fish, right? And okay, now I have to add something to the story. Maybe I talked to the fish and no, never mind. I won't talk to the fish. But I collected a sample that had 52% in my sample, regardless of what it was. Okay. And it was 52%. Now, yeah, there we go. So now I want to know, can I say that all the fish have a average proportion of 52? Or do I have to understand that like I could be off by a little bit, right? So in order to understand how far off I am, I have to create an interval. And the width of the interval will, oh, I gotta write these numbers down. Give me a second. There we go. Okay. So the formula says, I found a sample that's 52%. I can't really say that the population parameter is 52%. I'm pretty sure I must have gotten a sample that's close to it. So I better give an interval where I give you a lower bound and upper bound. So if I say 52%, how wide do I want to make my bound, right? Is dependent on how confident you want to be. So let's say I want it to be 80% confident, right? Do you see how the net's changing in width? Okay. If I want it to be 80% confident, I would have to center myself, my interval at 52, and then the 80%, which the math, we'll show you how the formulas work, but the math says if you want to be 80% confident, you have to have an interval that goes from 49% to 54.8%. Okay. If I were to say the true population proportion is somewhere between 49% and 54%, I would say I'm 80% confident that the queen fish or the queen population parameter is in that value, is in that interval. Okay. Now, I could be 100% confident because you're probably thinking, well, why don't you just crank it to 100%, right? Well, if you go very close to 100%, The net is so wide that look what I'm saying. I'm saying between 40% and 63%, right? That's like not going to be informed. It's not going to have enough information for you to feel it's useful. So when the professor was saying, how confident are you about my weight? I could tell him, I'm 100% sure that I bet my children's lives, my entire family lineage, I bet my entire reality that the professor weighs between 0 and 1,000 pounds. And you would say, well, of course. You see, that's too wide of an interval to be useful. I can be so confident, so sure that's between 0 and 1,000 pounds. That's his weight, right? But that's not useful information to you, right? So like I can say, between 0 and 100% of students at Cerritos College work part-time. You're like, oh, so you're telling me that it could be no one or it could be everyone. Do you see how that's not useful to be 100% confident, right? But if you start to decrease the confidence to like 90%, then you can give an interval and say, okay, I think that if I found a fish at 52% and I were to create an interval based off 90% confidence, I would say that my interval is between 48% and 55%, and I am 90% confident that I caught the queen fish, which is somewhere in there. Now, I don't know where it's at. Remember, you really don't know where this queen fish is because you don't have time to talk to the whole population.
We have a question.
Yes.
So population is just, so from your population, you're going to get your interval, right? Like those go hand in hand?
Yes, and yeah, they go hand in hand, but you won't be able to get the population. What we're saying is, in theory...
Oh, not the population. I mean your confidence percentage, that goes hand in hand with the interval, right?
Yes, it does.
Okay.
The interval increases. Look, so that's exactly what it means. Look, let's say I wanted to be let's say I wanted to guess your weight, Isabella, right? And I said it was 125, or no, let's say 130, right?
Okay.
If I said you're 130.238 pounds, that's what I believe, right? You're gonna say, like, should I be confident about saying that?
No.
Like, I bet watch.
Well, if you're that precise, wouldn't you be?
Say it again?
If you're that precise, wouldn't you be confident with your answer?
Well, it would be arrogant more than confident. Meaning, because it's dumb. It would be dumb on my part to say you weigh 100.237 pounds, right? And I bet my entire life, my kids, and my future on it, right?
Yeah, because you want more of like a range.
Yes, that's what I'm trying to get at. So now imagine if I made the range 130.2 pounds up to 130.4 pounds. Like I give a small smidget of a range, but I don't think I will be that confident to bet my future on that interval. You see? So now here's where I'm going to start feeling like 80% confident. You're probably between 125 and 140 pounds, right?
Yeah.
But now if I want to be 99% sure, right? Like I am so sure right now, 99% sure. I'm going to say between 100 and 160, right?
Oh, okay. I see. I get it.
Right? I'm like, I feel good about that, but I could still be wrong. Of course, I hope not to offend anyone, right? But if you were out that range, it'd be a small chance. And now why am I basing this on? I actually don't know, other than you're an athlete. So I don't know how tall you are, but I don't expect you to be, for a female, 170 is a little high, unless you have a good stature. If you're a volleyball player, you're 6'2", 6'1", then
no, I'm really short.
Right, but do you see what I'm trying to say?
Yeah.
So it was arrogant. It would be wrong of me to be so confident on a small level. But if I get it right, I'm being quite precise. So you the trade-off is precision for confidence. Does that make sense?
Yeah.
So if I were to be, so here's what I'm trying to say, like, to be more precise. I'm like, I captured a fish that's 52%, the population, no, the sample proportion is 52%. And I make this 20% wide. I can now tell Rashard, hey, I think the true population proportion between 51% and 52%. And then you're like, wow, that sounds great, Joel. I mean, if you can narrow it down to that from talking to just 100 fish, or, you know, just sampling 80 fish or a few fish, right? You would say, then you determined that? I'm like, yeah, but there's only a 20% chance that I'm right. You see? There isn't a great chance. And look, and then if we go, you know, and investigate more, you're going to say, look, Joel, you missed the fish. You missed the queen fish. You didn't catch her in the net. So you gave me a good window. You didn't have a high chance of catching it, and clearly you missed it. So I would increase that to 80%. Here's an 80% chance, and I catch the fish, right? But I happen to catch this fish here. That's because Rashard told me to stop. But next time she tells me stop, I may miss it. Do you see what I'm trying to say? There you go. Look, I just randomly stopped it. I might have gotten a sample that's 45%. And even with 80% confidence, my boundary still missed the fish. There's a 20% chance I missed the fish, right? And the important part is realizing that the likelihood of finding this fish over here is small. So that's what we mean by the curve. So I wish I had time to draw more fish here, but like there are clearly more fish that I can find here than there are here. Do you see? There's a few of them. So it's not likely that I'm going to find one of these fish. But if I do, it's an odd fish. Okay, let me explain. Imagine being an alien race and coming to planet Earth. And then first human you find, you say, that's probably how big humans are. Right? What are the chances that you randomly pick up Shaq and then leave the planet thinking that the human race is 7 feet tall, right? You see how there's few Shaqs around? Like there are 7 foot tall people on every continent, every country, right? But there's a handful of them. So to use that one fish as an estimate, you clearly wouldn't find many of those. So you're not likely to get it wrong. So most of the samples you're going to get are going to be in this range, you know. Obviously, let me draw. You know, most are going to be in here. 95% of them are going to be here. 99.7% are going to be in here. You see why we've been emphasizing the rules we've been giving you in terms of standard deviations? Oh, sorry. I'm trying to draw that last line. 97% over here. So it's very unlikely that you're going to find a sample that is far away from the true population parameter. And you want to make sure that you understand the difference between the confidence interval of means and the confidence interval of proportions. Does that make sense? Okay, so we want to now be able to interpret these sentences. So let me pull up the homework. Okay, here's the homework. Interpreting confidence intervals. From the 3 main points in the text, our interpretation of confidence intervals should include the parameter that is being estimated. So you're going to have to choose between proportion or means, and the context of that. Because don't just say, oh, the average is between this and this. No, you got to tell me the average height of soccer players, or the average the average number of drinks an adult drinks, or you can't say, oh, the proportion, the percent. You got to be precise. The percent of smokers or the percent of people who work part-time, or the percent of people who will vote for a certain candidate, okay? Number two, the level of confidence that's being used. So how confident you are, 80%, 90%, 88, 95, whatever. And then the boundaries, the upper and lower bounds of the interval with context and units. Making sense? So here's an example. Given a 90% confidence interval for mean time in seconds of salmon run Splatoon 240 to 260. You would create the sentence, we are 90% confident that the times between, I would add the word between here, between 240 seconds and 260 seconds contains the mean time for all games of the salmon run in Splatoon 2. Note, the interpretation above satisfies all three, right? The mean time is a parameter, 90% is a confidence level, and the lower bounds and upper bounds using units. Okay, so here's one, right? Proportion of US citizens that travel overseas, this number, this confidence level. So, which phrases in the interpretation above correspond to each requirement? So the interpretation here, whoops. Okay, so the interpretation is with 95% confidence, the proportions between 3.77% and 4.74% contain the proportion of all US citizens who travel overseas. So what is this first one here?
The proportion of all U.S. citizens who travel overseas?
Yes. Let me get that comment tool out.
With 95% confidence?
Yeah. And 3.
The proportion between 3.77% and 4.74%.
Okay. So proportions, yeah, they're not going to have units because those are just percentages. But there's going to be times, careful, where if you see a percentage, it might have a unit in terms of points, like for an exam. But that's the only version I think might have units. Even then, most percentages don't have units because you have, unit over unit, and then when you divide the units, they cancel out, and it turns into a unitless number. Okay, your turn. Someone for spins and VP points. You're simply supposed to write a sentence that contains all three key phrases given this information. Anybody?
You want me to just read it?
To verbally say your sentence. What sentence would you write if you were given this what would be the interpretation?
I would write, with 99% confidence, the mean hospital cost for accident victims who are wearing seatbelts is $5,403 to $12,605.
Dollars. Right?
Yeah.
So with 95%, profit. The mean hospital. Sorry. And then I would emphasize, you also skip the word between. So it is between. You don't always have to put between depending on the grammar, but you can't say that the cost is 5,000 for and 12,000, because then it sounds like you're saying two values, that it costs someone 5,000 and it costs them 12,000, right? But if you say that the cost is between 5,000 and 12,000, then you have the interval. Oh, and then I could just add the dollar units here. So obviously you could do that, or you could have said between 5,403 and 12,605 dollars. You could put the unit after. That's just, the dollar one is weird because it's literally a symbol you could stick on at all times. But you could do that with feet too. So maybe next time we'll get one and you can put feet. Okay, here we go. Oh, who said that, by the way? Can you give them points, Justin?
I got it.
Okay. Next person. Try this one out.
With 92% confidence, the proportions between 1.74 and 2.24% contain the proportion of South Koreans who smoke.
Good. Yeah. And I don't think I can recall the order in which you said that, but I'll try my best. No. Well, yeah, just I'll type it on and tell me if I got it wrong with 92%. You said the true proportion, right?
The proportion.
Okay.
Yeah.
Yeah. Yeah, no, you're good. I would add the word true. It emphasizes that there's a value out there that exists while our sample is an estimate. So there's a difference between our estimate and then the real value. So we're 92% confident the true proportion of, go ahead.
Between 1.74% and 2.24%.
Oh, okay. Wait. I think I messed up the order percentage. We are 92% confident the proportion. Now I get what you're saying. The proportion is between 17.4% and 22 point. Like that, right?
No, it's 1.74%. Oh wait. Oh no, you can be like that. That's good.
Hold on, everybody. Is this 1.74% or is it 17.4%?
17.4%.
Okay. So, go ahead.
Contains the proportion of South Koreans who smoke.
And that, you see where I added the word true?
Yeah.
Cool. Okay. And I don't want you guys to get in the habit. I mean, it's fine. With 95% confidence, this is stated. You could also say we are 90% confident, right? So I just Actually, do it with as much as you want, but I'm just realizing how as many times as I've done it, I'm not as comfortable with that because I've never heard that phrasing. I've always started off the phrasing with, we are 95% confident that so and so and so. But there's nothing wrong about any of those. Right?
So we can put either with or we?
Yeah. Uh-huh.
Okay.
Okay. All right. So it's 4 o'clock. You guys have an idea of how this is going to work? Right? Be precise about the parameter, right? Don't just say the proportions, like here, based on the order that you say it, at least we know it's a proportion of Koreans who smoke. You know, we don't just say it's a proportion of people who smoke. So be precise about the population. That's pretty much, I think, the one that people miss the most, and then maybe units is the most common mistake. Okay. And everybody understand the big idea too, that we probably didn't talk to audience, right? Everybody know that, right? Well, we're just getting into the subject of confidence intervals, so we haven't talked about sample size, but I'm assuming that it could have been something like was maybe they talked to 1,200 Koreans, and I can't tell you what they got in their sample though, because this has a center. Can you guys find me the center of this interval? This is huge, actually. This is probably what we're gonna do tomorrow. Like, this is where the math starts to come in. So, like, anybody have an idea where the middle of that interval is and how to find it? Like the exact middle. So we're talking about just finding the midpoint.
Probably like 0.19.
Okay. And how'd you find that?
I just guessed.
Oh, okay. No, we got to be able to calculate that. Precisely. So yeah, you're right. You're right. It looks like it's about 19, but I need it exact.
How would you get the exact answer?
Well, that's what I'm asking. Can someone figure out a mathematical way to add, subtract, or divide, or cut, or kind of give?
I think it's like subtract.
Okay.
Subtract.
If you subtract, what do you think you're going to do with the subtraction?
We said 19, right? Like subtract, like just 1%. And then add to the other one.
But hold on, but how do you know it's 19 though? That's what I'm saying. Like,
okay, I don't know.
But no one can find the middle?
Don't you add those two together and then divide it by 2?
Yes, who said that?
Bertha.
Me.
Bertha? Okay, you get literally 3 spins. Okay, did everybody get that? Look, if I want to find the middle between 10 and 16, you know it's 13, right? Or I could be wrong. Yeah, it's 13, right? That's easy to figure out, right? The middle between 10 and 20 is 15. Easy to figure out because you just kind of know it. But if you take Bertha's advice, you add these two, what do you get?
30.
30. And 30 divided by 2?
15.
Okay, add these two, 26 divided by 2, 13, right?
So add and divide, right?
Add the lower and the upper and divide by 2. So if someone find the center now of this thing.
0.199.
Okay. 0.199. Divided by 2. Yep. Okay. So now I know that when they talk to the Koreans in the sample, they got 19.9%. Now I am making this up, so don't always understand what I'm making up and what I can confirm. This I can confirm for sure. They must have got 19.9% when they talk to people. I'm just saying, if they were to talk to 1,200 people, that means that 19.9% of 1,200 people would mean 238.8. So obviously that wouldn't work because you can't have 230.8 people say yes, right? So maybe it was like 2 out of 1,200 and 239 out of 1,200 rounds to that same value. Does that make sense? Right? Like take a calculator out now to see what I'm saying. Like take 239 divided by 1,200 and you get a percentage very close to this that you can round value. So I want you to imagine the whole scenario so these numbers make sense. Like, who wants to know what percent of South Koreans smoke? And you know, you probably say like, I don't care. And then someone in the health department, right, in the country says, yes, I would like to know that. It's an important statistic for the city, the county, the mayor, whatever you want. So they say, okay, how are we going to find this out? Well, you go out, get 1,200 people, ask them yes or no, you smoke, yes or no, you smoke. I got 239 yeses as an example, right? And then I got 19.9%, and then I created an interval with 92%, and I created this, right? Later, though, I'll be more precise about, I think, I'm not really sure, but I think I could figure out the sample size for that. But that might not be the correct sample size. I just made that up right now. Okay, so stop by tutoring. Hope you guys can get through that first worksheet, and have a good day.
Cool. Later, guys.
Bye.
Bye.
Hey, Jesse, anything I should know about the meeting? Actually, wait. Let me stop recording because it's, private.